Hello guys, welcome to today's class on mathematics. So today we are going to be looking at Venn diagram. So we are still on set. Okay, so Venn diagram is one of the diagrams we use to describe a particular set or the activity for a particular set or different sets. Okay, so now in Venn diagram we normally use a square box or rectangular box in this form. Normally use this rectangular box to describe this Venn diagram with a sort of circles inside of this rectangular box. Okay, so today we are going to look at the two sets problem. Okay, when we are only having just two sets, we still have a case where we can use the Venn diagram to represent a three sets problem. Okay, so for the two sets problem, we have, let's say we have a set A and we have set B. Okay, now and everything inside here contains this set A and set B. Then inside here, or all we have, including the rectangular box, we refer it as the what? As the universal what? Set. Okay. Now let us consider different cases in this rectangular box or in this Venn diagram. Now the first one, we have case I, we have case 2, case 3 and case 4. So for the first case, we say that this means that A intercept what? B prime. Okay, that means that we are only looking at A what? Only. So this shaded part now, okay, this shaded part is our what? Case 1. Are we together? Because that is what? A what? Only. So A only can be represented with A intersect B what? Prime. Alright. Then the next case is case 2, where we have A intercept what? B. Of course, you see this is the point where A and B what? Intersect. Okay. So we call such the A intercept what? B. Now the next case is the third case here, where we have that A prime intersect B. Okay, that is, we are looking at B what? Only. So if we are to shade here, this is the third part there, or the case 3, where we are looking at what? B what? Only. So that is what it means to say A prime intersect what? B. Okay. Now the fourth case is where we have A prime intersect B what? Prime. Or we can say A union what? B or what? Prime. So that is for this case IV. That means we are looking at the elements that are in the universal set, but they are not in A and what? And B what? Set. Alright, so that is some of the things you need to know for the two sets problem. Now we have this general representation of a formula to use to solve for the two set problem. We say that the number of A union B is equal to number of A plus number of B minus number of A intersect B. Okay, now let's use this question to explain that. Okay, now we have the first question there. It says, suppose the academy said that 600 students entered for mathematics and 300 entered for physics, while 173 students entered for both mathematics and physics in the examination. How many enrolled in the two courses together? Okay, now we have that from the question. We have 600 students entered for what? For mathematics. Okay, 600 students entered for mathematics, and we have 300 students entered for physics. Okay, then we also have that the point where physics intersects with mathematics, we have 173 students. Okay, So now what we are going to do is we use this formula. We are going to have that the total number that is A union B altogether for the two courses, that is the total number of students that will enroll for the two courses, is N, the number of A union what? B. Now we say it is equal to the number of A. It is equal to, this time we are going to be using N, and what? We are going to be using what? P. Are we together? Alright. So this will be N, number of M union P is equal to the number of M plus the number of P minus the number of P intercept M. Okay, now if we have to solve that here, we are going to have, this will give us that the number of M intercept union P will be equal to, number of M there is 600 plus number of P there is 300 minus number of P intercept M is 173. Okay, so if we add up 600 plus 300, we have 900 minus 173. Okay, so if you point that in your calculator, you are going to have 7 students. So we have 7 students. And the total number of students that will enroll for the two courses. So that is how we solve for that. I hope we are okay with that. Alright, so we'll still take more examples on this in the next video to see how we can